I was looking through the research for today, and I had this kind of funny thought. We treat our smartphones way better than we treat our own bodies.
This is a bold way to start. How do you
Well,
mean?
just think about it. When your phone gets,
Yeah.
apps crashing, the battery dies in 2 hours, it's overheating.
Yeah.
You don't just like buy a new case for it.
Right, you look at the software.
You check the software. You might even do a hard factory reset.
Sure.
But with diet, we are obsessed with the case. It's all about weight loss, fitting into jeans, counting calories.
Yeah.
It's all external stuff.
That is a perfect analogy, actually. We are always focused on the aesthetic, not the operating system. We treat the body like it's this static thing. You pour gas in, it goes.
But it's not.
No, biology is plastic.
Yeah.
You are literally rebuilding yourself minute by minute based on the information you give it.
Yeah, exactly. And the research we're getting into today, this is the factory reset. We're doing a deep dive into the biochemistry of the carnivore diet. And I want to be super clear for everyone listening. This is not about, some guy on TikTok. And we are not here to debate ethics or the environment.
No, this is strictly mechanics today. We're looking at mitochondrial regeneration, isotope physics, metabolic optimization. It's surprisingly technical, but it really changes how you look at food.
The whole premise is basically asking, what if we stopped looking at food as just fuel and started seeing it as a software update for your cellular hardware?
And if you're listening and you deal with that dreaded, 2 p.m. slump where your brain just feels like it's wading through mud, this really matters.
Oh, yeah.
That slump isn't a character flaw. It's a bioenergetic crisis. It's your mitochondria, your cellular power plant sputtering. And this is an intervention designed to stop that sputtering.
Okay, so let's get under the hood. The research talks about this switch to a super fuel. Now, my skepticism radar goes up a little with marketing terms like that, but the chemistry here is actually about thermodynamics, right?
It is. So to get it, you have to look at what happens when you cut out carbs completely. Your body is forced into what's called nutritional ketosis. You stop burning glucose or sugar, and you start burning fat.
Which is the basic keto pitch we've all heard for years.
It is, but we have to go deeper than just fat burning. Your liver takes fatty acids and converts them into ketone bodies, and one in particular called beta-hydroxybutyrate, or just beta-HB.
Okay.
Now, here's the physics part. Beta-HB is a thermodynamically superior fuel.
Superior how? Like higher octane for your cells?
Literally, yes. It increases something called the delta G of ATP hydrolysis. In plain English, you get more energy, more ATP molecules, for every single unit of oxygen you breathe.
So if we're using a car analogy, we are actually getting better gas mileage.
Significantly better. And this is so crucial because for a lot of people, the mitochondria are aging or they're damaged. They struggle to use oxygen efficiently. If you feed them glucose, it's a heavy load on that system. But if you switch to ketones, you get this high energy output with way less strain. It's a cleaner burn.
I get the mileage argument. But the note said beta-HB does something else too. It's not just fuel, it's a messenger.
This is the part that usually blows people's minds. Beta-HB is a signaling molecule. It inhibits these enzymes called HDACs, histone deacetylases.
Okay, you got to unpack that. What does inhibiting an HDAC actually do?
Think of HDACs as locks on your DNA. Beta-HB comes along and unlocks them. It literally flips genetic switches that turn on your body's own internal antioxidant defenses.
Whoa.
So the fuel itself is telling the factory, hey, while I'm here, let's upgrade the security system.
That is incredibly efficient. It's like putting premium gas in your car, and the gas itself tells the mechanic to go fix the brakes.
That's a fantastic way to visualize it. But the efficiency isn't just the fuel source, it's how the fuel is processed inside the engine. Which brings us to the electron transport chain.
Oh, man. I'm having flashbacks to high school biology. The diagrams with all the little circles and arrows, it looked like a crazy pinball machine.
It is basically a pinball machine. Imagine a series of stations complex 100, 3, and 4. Electrons bounce through them to make power. But here's the problem. On a modern diet, we are just flooding the system with glucose.
And in this pinball machine, where does glucose enter the game?
At the very beginning, complex 1.
And that's a problem, a choke point.
It's a massive bottleneck. When you overfeed on carbs, complex I gets completely overwhelmed. The electrons back up, they leak. And when electrons leak, they react with oxygen to create reactive oxygen species.
Oxidative stress.
That's oxidative stress. That's the smoke coming out of the engine.
Yeah.
You're making energy, sure, but you're creating so much exhaust that you're literally rusting out the engine from the inside. It's a huge driver of inflammation.
So how does this approach fix the traffic jam? Just by taking out the sugar?
It's more active than that. The fatty acids from animal fat, they produce a different electron donor. It's called FADH2, and this donor skips complex A completely.
It has a VIP pass?
It goes straight to complex 2. It just bypasses the bottleneck, so you get all the energy flow, but you drastically cut down on the electron backflow. Less smoke, less rust.
Okay, so we've switched to a cleaner fuel, we've rerouted the traffic. But a factory also needs raw materials, right? The source material highlighted some specific nutrients in meat that act like a support crew.
Right, you can't just run the machine, you have to maintain it. And this is where that whole nutrient density argument really comes into play. It's not just protein. It's these functional compounds that make energy production possible.
The first one that jumped out was L-carnitine. I feel like I see that in energy drinks, but I'm guessing in nature it does more than just give you a buzz.
Way more. And yeah, it's found almost exclusively in red meat, hence the name carnitine. Think of L-carnitine as the shuttle bus.
A shuttle bus for what?
For the fuel. Fatty acids are big molecules. They can't just wander into the mitochondria. They're too big. They need a shuttle to get across the membrane. L-carnitine is what physically carries them inside.
So if you're low on carnitine.
The fuel just piles up outside the factory door and the engine starves. This is actually a really common finding in chronic fatigue syndrome, a functional deficiency in the shuttle. You have the fuel, but you can't get it in the engine.
So the diet basically floods the system with the buses to get things moving again.
Exactly. Then you've got CoQ10.
That's the anti-aging one, right? It's in every face cream.
They do, but it works from the inside out. CoQ10 is abundant in heart and muscle meat. In our pinball machine, CoQ10 is the carrier that moves the ball between the flippers. It shuttles electrons, but it's also a shield. It sits right in the membrane and protects it from that smoke.
A carrier and a shield, that's efficient.
Nature usually is. But the one I think is most overlooked is taurine.
Again, I'm thinking energy drinks.
Right, but biologically, taurine is fascinating. It is essential for modifying something called tRNA inside the mitochondria.
Okay, you're going to have to help me with the tRNA thing.
Okay, imagine you're building a Lego set. The tRNA brings you the right bricks. If you don't have enough taurine, the tRNA isn't modified correctly. It's like trying to build a Lego set with warped bricks.
They don't click together right.
They don't. You end up building misfolded proteins. The mitochondria tries to build a new engine part, but because the pieces are warped, the part is just dysfunctional. Taurine makes sure the Lego pieces are perfect so the machinery is built to spec.
It's incredible how specific these are. It's not just multivitamins. It's these very precise compounds, carnitine, CoQ10, taurine, that keep things running right.
Precision is everything in biochemistry. And speaking of precision, we need to talk about the part of this that honestly read like science fiction.
I know exactly where you're going. The subatomic healing part.
The deuterium story.
I had to read this section 3 times. It felt like I'd stumbled into a physics paper. We're talking about heavy hydrogen. It sounds like something from Star Trek.
Yeah.
The deuterium core is failing. What is deuterium, and why is it the bad guy here?
It's actually basic physics, but with this wild biological twist. So normal hydrogen has 1 proton, 1 electron. Deuterium is an isotope. It has a proton, an electron, and a neutron.
So it's physically heavier.
Twice as heavy.
Right.
And twice as bulky. Now, normally, who cares? But remember that ATP synthase we talked about, the thing that actually makes the energy?
The nanomotor.
Yes, it is a literal molecular motor. It sits in the mitochondrial membrane, and it spins at around 9,000 RPM. And it's designed specifically to accept protons light hydrogen.
I think I see where this is going. If you shove a heavy, bulky atom into a tiny motor spinning at 9,000 RPM.
It's like throwing a rock into a jet turbine. It causes stuttering, it creates friction. Over time, it physically breaks the nanomotor. This deuterium accumulation is now being identified as a primary driver of aging and metabolic failure. The motors break, your energy just plummets.
So we need to keep this heavy hydrogen out of our engines. How does eating meat and water do that? The term they used was depletion.
Right, depleting deuterium. It happens in 2 ways. First is source control. Grass-fed animals are kind of like a biological filter. They process plants and water, and they filter out deuterium. So their fat is naturally lower in deuterium than, say, carbs from fruit, which actually concentrate it.
So you're eating light food.
Isotopically light, yes. But the second way is even cooler. When your mitochondria burn fat, they produce water. We call it metabolic water.
We make our own water. I thought we just drank it.
We do both. A camel survives on this. It burns the fat in its hump to create water. Humans do the same. And the chemistry shows that water created from burning fat is significantly lower in deuterium, like 118 parts per million compared to tap water, which is closer to 150.
So by burning fat, we are literally bathing ourselves in this ultra-pure, low-deuterium water.
Precisely. You are flushing out the heavy, damaging isotopes and lubricating those nanomotors with the exact fluid they were designed for. That's the subatomic healing. It lets the motor spin freely again.
That just reframes you are what you eat down to the atomic level. It's not just about calories. It's about the literal weight of the atoms.
It is. And once you've cleaned up the fuel and fixed the motor, you have to look at the structure. Mitochondria aren't static. They're constantly moving, merging, and dividing. It's called fusion and fission.
And this is where that fat from beef tallow comes in.
Yeah.
Stearic acid.
Yes, stearic acid, C18.0. It's a long-chain saturated fat. And it turns out it acts as a signal. It tells mitochondria to fuse together.
Why do we want them to fuse? I would have thought more individual ones would be better.
Not necessarily. Think of fusion as sharing the load. Yeah. Let's say you have a mitochondrion with some damaged DNA. It's struggling. If it fuses with a healthy one, they mix their contents. The healthy one shares its good proteins and DNA with the sick one.
It's a rescue mission.
It is. They form these long, super efficient networks. It rescues organelles that would otherwise just die off. And stearic acid is the chemical signal for that to happen. Research on chronic fatigue often shows fragmented mitochondria. They aren't fused, so they're weak.
So the tallow is the command to link up and support each other.
And at the same time, the diet stimulates a pathway called PGC1 alpha, which tells the body to build brand new mitochondria. So you're recycling the old broken parts, that's called mitophagy, and you're building new high-performance hardware. It's a total factory overhaul.
Okay, let's just recap the mechanics because it's a lot. We have the fuel switch to ketones for better mileage, the bypass of the complex I-traffic jam to stop the smoke, the nutrient support crude carnitine, CoQ10, taurine, the subatomic flushing of deuterium, now the structural repair with stearic acid.
It's a complete system. That's why the sources call it a reboot.
But what does this mean for the person listening? Mechanics are cool, but you mentioned chronic fatigue syndrome, or MECFS.
This is the so what of it all. If you look at MECFS, it's basically a cellular brownout. The grid can't meet the demand. Patients get brain fog, muscle weakness, that awful post-exertional malaise. The research suggests it's a functional mitochondriopathy. The mitochondria are sick.
And based on everything we just laid out, this approach seems to hit every single one of those weak points.
It does. It stabilizes brain fuel with ketones, which helps brain fog. It provides the carnitine shuttle that's so often deficient. The stearic acid promotes fusion to repair the fragmented networks. It's not a magic cure, but it addresses the specific mechanical failures you see in those conditions.
What about autoimmunity? The outline mentioned the elimination protocol, because a lot of people try this not for energy, but because their body is attacking itself.
That's the other side of the coin. Everything we've discussed is about what you add, the good fuel, the nutrients. Autoimmunity is often about what you remove.
The plants.
Specifically, their defense chemicals, things like lectins, oxalates, phytates. If you have a healthy gut, maybe it's fine. But if you have intestinal permeability, leaky gut, these compounds are like sand in the gears. They irritate the gut lining, they trigger the immune system.
So by taking out the plants, you remove the sand.
You remove the constant irritant. And at the same time, ketone bodies, remember beta-HB, they've been shown to help regenerate intestinal stem cells. So you're healing the gut barrier from the inside. You stop the things from leaking in that were triggering the immune system in the first place.
It's fascinating because the sources are so careful to frame this neutrally. It's not everyone must eat only meat forever. It's if the machine is broken in this specific way, here is a potential engineering fix.
Exactly. It's an intervention for dysfunction. If your car runs great on regular, fantastic. But if your engine is knocking and stalling, maybe you need the high-octane overhaul.
Before we wrap, there was one last concept, mitohormesis, which I have to say sounds like a great name for a heavy metal band.
It does, but it's this beautiful biological concept. It just means good stress.
Like exercise.
Exactly like exercise. When you make this dietary transition, it causes a tiny bit of initial stress. It's a shock to the system. But that tiny specific stress triggers the body's master defense system, a pathway called NRF2.
So the transition itself acts like a vaccine for stress.
In a way, it trains your body to build a much stronger internal antioxidant defense system. You don't just get back to where you were. You end up more resilient than when you started.
Which is the ultimate goal, isn't it? Resilience. We talk so much about losing 10 pounds, but what we really want is a machine that can handle whatever life throws at it.
We want the engine to hum.
So here's a thought to leave you with. We tend to think of simple things as primitive. A diet of just meat and water seems crude next to a supermarket with 40,000 process options. But if our cells are literal combustion engines, maybe we've been clogging the intake with incompatible parts for so long that we've forgotten what it feels like to run smoothly. Maybe, biochemically, the simplest diet is actually the most sophisticated engineering fix there is.
It's a compelling question to ask yourself next time you're standing in the grocery aisle.
Thanks for diving deep with us. We'll catch you on the next one.